you can see that from here, we have been asked to calculate a number of things, the number of moles at equilibrium, calculating the concentration of the different reactants and products at equilibrium, writing the equilibrium expression for the concentration Kc, and calculating the Kc and give the units. Altogether, 8 marks. The first thing we have to do in this type of reaction is this. You have to write a balance equation, and the equation was given. A plus B, plus B, all gaseous reaction at equilibrium gives a C. All are 1 mole, 1 mole, 1 mole from the balance equation. The first thing in this, we have to construct what we call an ice type of table, an ice table. Initial, that is the moles at the initial, then the change, what has happened during the reaction, then at equilibrium, what do you have? Initially, from the data that we have been given, we were told 0.1 mole of A and 0.2 moles of A are in a reaction mixture. These are 0.2 moles per 1 mole of A initially, that is I, 0.1 mole and 0.2 moles. Here, initially, C is 0. The product C, the number of moles were not given. What has changed? In a reaction, in a chemical reaction, where products are being where reactants are being converted to products, what happens is that the concentration of the reactants decreases while the concentration of the product will increase. Since we have been told that A and B, they reacted in a reaction mixture, in a reaction mixture, A and B give rise to 0.04. A and B reacted together to produce an equilibrium mixture containing 0.04 moles of C. Equilibrium mixture containing 0.0 mole of C. What do we do? Since reactants are being converted to products, they are decreasing in concentration, and the concentration of the product is increasing. Let's assume to the at equilibrium there, let's assume the change that is taking place, that as the reaction is taking place, the concentration of the reactants are being converted to product. In that case, their concentration are decreasing. And we assume the number of moles that are reacting or that are taking place at that time to be X. If they are X based on our balance equation, just one here, and one here, one mole of A reacting 1 mole of B to give 1 mole of C from our balance equation. The change here should be, if we assume to be an X, it should be a minus X because the concentration of A are decreasing. It should be a minus B because the concentration of C are decreasing, of B are decreasing. But we were told A and B reacted together to produce 0.4 moles of C at equilibrium. The equilibrium mixture contains what? 0.04 moles. We have to develop this equation. Since we have not been given the Kc that we can calculate, we have to do this. Now, secondly, what will definitely happen when the equilibrium is established? When the equilibrium is established, that is E, we have the initial moles, plus the change that was taking place will give us what is taking place at the equilibrium. And since we add initial moles and the change, it will give us what is taking place at the equilibrium. So we now say, since this is minus X, it is 0.1 minus X. Since this is minus X, it's 0.2 minus X. And at equilibrium, the value of C was given. Now, this is the equation. We have not been given a Kc. In order to establish this, we were told, again back to the equation. A and B reacted together to produce an equilibrium mixture of 0.04. If A and B reacted together and produced 0.04, and we assume A to be X, and we also assume B to be X, so they have just 1 mole, we can now say X plus X will give us 0.04. We assume X plus X will give us 0.04. At equilibrium, it will be 2X equals to 0.04. And the value of X will definitely be 0.02 moles. Substituting this value in our equilibrium expression here, equations, to have the value of A after the change has taken place will be the initial number of moles minus the using 0.1 minus X. If we substitute X to be 0.02 here, our value of A, the number of moles of A at equilibrium will be 0.08 moles of A. If we go to B, we come here and we want to substitute the value of B. We want to substitute here, this is B, which is 0.02, and the equation of B is 0.02 minus X. And we substitute in our equation here to find the number of moles at equilibrium. It will be 0.02 minus 0.0, it will be 0.2 minus 0.02. The number of moles at equilibrium will be 0.18 moles for B. Now, for C, we were told A and B reacted and gave 0.04 moles of, the reaction mixture gave 0.04 moles at equilibrium. So C is 0.04 moles. Now, the second part of the question says, calculate the concentrations of A, B, and C at equilibrium. Concentrations. The concentration is usually measured by mole per dm cube. So we have the number of moles, and they were told from the same equation, equation that the total volume of the mixture was 2 dm cube. And the expression for concentration is moles per dm cube. That is the number of moles of that substance divided by the volume in mole dm cube. So if we take the different moles of the reactants and the products, and we divide it by the total volume, which is 2 dm cube, we will have the different concentrations. For instance, the concentration of, if we divide it by the total volume of the reaction, it will be 0.08 divided by 2. That gives out 0.04 mole per dm cube. That will be the concentration for A. If we do the same division here for B, it will be 0.18 divided by 2 dm cube. That gives us 0.09 mole per dm cube. And the cell with the set, the reaction mixture gave 0.04 moles of C. At equilibrium, C had 0.04 moles. If we divide it by the total volume of the mixture, which is 2 dm cube, we will have 0.02 moles of C, a mole per dm cube of C. That is the concentration for the C. Mole per dm cube for C. Now, these are the different concentrations of A, B, and C. There's one thing I want you to clear off before we can proceed. Remember, if there was 2 moles here and 1 mole here and 3 moles here, the X will definitely be -2. If A was 2, it was 2. From the balance equation, if A was 2, it will be -2X. If B was 1, it's just -X. If C was 3, it will be +3. So you have to write the values of the X based on the balance equation, please. Let's proceed. Thirdly, the question says, calculate the value of, write the equilibrium expression for Kc. Kc is the equilibrium expression for the concentration. The equilibrium expression for the concentration, as we said, Kc is usually expressed. This is usually the product of the concentration, the product of the concentrations of the products divided by the product of the concentrations of the reactant. The square bracket represent symbolically the concentration. So the concentration of the product divided by the concentration of the reactant, all raised to the power of their coefficient. A is just 1 mole, so it's just 1. There's no need writing a 1. A is just 1 mole, is 1. There's no need writing a 1. So anything raised, no need writing a 1 here. B is still just 1 mole that was reacting, so it's just 1. So everything will be the concentration of C. Kc will be equal to concentration of C divided by the product of the concentration of the reactants. And now, we went further and they asked us to look for the number of the units. So it will be mole per dm cube divided by mole per mole per dm cube times mole per dm cube. We will have per mole dm cube. Now, calculate the value of Kc. The value of Kc, since Kc is the concentration of the product divided by the concentration of the reactant, product of the concentration of the reactant, merely substituting the concentration. Remember, please, do not use moles when it comes to calculating Kc. Use but the concentrations, because the square bracket indicates the concentrations. So we have to use but the values for the concentrations of A, B, and C in calculating our Kc, not their moles. So if we substitute their concentrations in this expression here, we will have, because the concentration for C is 0.02 moles, the concentration for B is 0.09 moles per dm cube. The concentration for A is 0.04 mole per dm cube. If we substitute all this in the Kc expression, we will have 0.02 divided by 0.04 times 0.09. And if we calculate this, we will have 5.6 mole, 5.6 per mole dm cube. That will be the value for the Kc. If we do that correctly, then we will have our answer. Thank you. Our next answer here will be, our next question will be how to calculate the number of moles in a reaction like this other one. A reaction like this other one here, that has to do with number of moles. It has to do with the number of moles